Okay, guys, we're back here. Let's go ahead and look at 6-1, continuing it. So regarding that one, this is the first one, 1x plus 4. I'm going to go up to 4, do a slope of rise 1, run 1, and the line goes like that. Okay, this one right here would be a -4, 1, 2, 3, 4. I'm going to do a down 1, over 1. So it's basically 1, 1. They cross here. I'm going to just 1, 1, 1, 1, 1, 1. See, I've gone up 3, so I should overrun 3. 1 more, that's 4. So I'm looking at that as a -4, 0. Now I should plug it into both of them and check it out. So 0 would be here, and I have actually no, the other way. -4 here and 0. And it checks out. You see that? I plug it into the bottom one here, and I have 0 is equal to a -4 minus 4 plus 4 minus 4 checks out for that one. So that's my answer for that one. Check this one out. Get any other way. +3, 1, 2, 3. It's better if your lines are straight. Up 1, over 1. 1, 2, 3. Okay. This line go up to 4. 1, 2, 3, 4. Rise 1, 1, 2, over 1. So I would go down 2, over 1. Oh, that's a number right there. So boom. That's where they cross. Okay, so that one right there, that would be a -1, 2. -1, 2. Now I'm going to check if they work. Now that part, if they see if they work, let's see what they do. Plug it into the first one right here, okay? So I'd have 2 is equal to a -1 plus 3. Checks out. You can do that math in your head. When you go 2 is equal to a 2 times a -1 plus a 4. -2 plus 4 gives me 2 is equal to 2. Checks out. So that's my solution. Pretty cool. What? Not too bad? Not too bad, right? So we're going to leave that there. We're going to move on to some word problems now. They're all basically the same. Yes, the numbers do change. Yes, they do intersect at different, harder, more different, farther away spots. Hey, you got to work. Let's look at the word problem here. Okay. So in all of this madness, I'm going to step back real quick. Make sure you know this. We always can go back to y equals mx plus b. Your b is your starting point. Make sure you know that. Your m is your rate of change. That's where we first introduced your stuff, guys, as a rate of change. So if you hear a rate, okay, you hear a per, and each, every. Anything that talks about rate of change, that's your slope. The other number that they're going to give you is your starting point, and that's it. So here we go. Alberta are reading graphic novels. Alberto, Shanti. Okay, write an equation each. Okay, so Alberto. Right here, Alberto reads that many pages and per day, each day. So this is your M, and this is your B. So for his equation, we're going to have Alberto is equal to, okay, it's Y, right? But I want you so I can keep my mind straight. Alberto is equal to 20x plus 35. Ashanti. Alberto, Ashanti. Okay, let me do Alps, you don't mind? Yeah, and then we'll do Ash. Is equal to, look, that's his B, and each day is your M. That's the way it changes. That's your rate of change. So we're going to go out here and go with 10x plus 85. So that's A, but boom. Now, coming out here, it says graph both. So I'm going to try this one. Shoot. 85, 35, so So let me see. So I'm going to have to make this graph a little bit bigger than what I'm wanting to, but whatever. Okay, I'm going to extend this up here. What do you count by tens or what? Okay, we'll go by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, I'll go with 10 so I can give myself an idea. I'll go with this person here. So Alberto will start at 35, 10, 20, 30, 5. That's the starting point. 20 up. Okay, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I'll go 1, 2, 3, 4. You got mine? This is over 1. This is over 1. So I'm going to keep it real simple. Over 1, and that's it. So I rise, run 1, and that's it. No big deal. So for this person, starting off at 35, you go 20 up, 10, 20, over 1. Okay. Now let's look at this. Remember, let's just talk about what these things are. Since this is each day, these are your days. Okay. This is pages. Does it make sense now? Come on, 20 pages each day. If I go over 1 day, he should have increased 20 pages, right? Okay. Ashanti now, let's look at this person over here, 85. So that's at 85. So that's 90, 85 is right here. What? 10. So it goes up 10 over 1. So if you look at this, oh, great. This one should be a little steeper. They're going to cross. They're going to cross somewhere there. What do you think about this? How many days do you think this is? And about 5, 6, 7. How long will it take before Alberto can read more pages in Ashanti? You ready? This graph should be better to read it better, but let me just go ahead and see what happens here. What do you think? 5, 6. Let's try 6. For this person here, at 6 pages or 6 days, we're going to have 20. I'm going to try 6 if you don't mind. At 6 days. At 6 days, this person has 20 times 6. Out. Plus the 35 he originally started. So he'll have 120 plus 35. So Al would have 155 pages. Okay? As we get an idea. Over here, let's see this person. Ash would have the same time, okay? 6. 10 times 6 days plus 85. What is that? 60 plus 85. That's going to be 100, 140, 145. Boom. Hey, my graph's pretty good, I think. About 6 is pretty good. Okay, I'm going to just try, guys. Let's try 5. Okay, let's try number 5. Let's try 5 days. Okay, so the question's asking, how long will it be before Alberto has read more than Ashanti? So if you look at this one, Alberto is what? Below the red, right? The red one? And he's below. Every day, they're increasing. Do you agree? Every day, they're increasing. Now, every day, this person doesn't increase as much as this person. This person started off with less books, but his rate of change is more. So as the day goes on, his increases more / his slope is steeper. This person doesn't increase as much, so they will cross. And this guy will eventually taking, a higher book, pages read. What day? And they about 6. Try 5 days. Let me see. For this person up here, you have 20 times 5 plus 35, 135. Okay, let's try Ash. Ash would have 10 times 5, right? plus 85. What would that be? 50 plus 85. Oh, at 30. It'd have 135. Both of them. So at 5 days, they're equal. Okay. 6 days. 6 days, Ashanti has read more. Oh, my bad, my bad. Alberto has read more at 6 days. And at 5 days, they're equal. Question is, how long would it be before Alberto has read more pages than Ashanti? Before he has read more. So, well, I'm going to go with, I understand the question that well. I'm going to go with 6 days, he's more. 5 days are equal. You want that one? Okay, that's a good question there. Good. Hopefully you got it. Let's come back here and practice another word problem. Okay, here's a word problem from the book. Now, the number of girls participating in a high school soccer and track and field has steadily increased. That's your rate of change. That's your slope over the past years. Guys, since they said steadily, okay, that kind of means like it's a steady rate of change. Using information in the table predicted to approximate year, the approximate year when the number of girls participating in the two sports will be the same. Okay, so girls, look at this. The first year is this much, second year is this much. Guys, there's your 2 points. You got it? Those are your 2 points. So the rate of change, how much has this changed? You get your slope, guys. You get your slope. This is, time is always your x, okay? This is x1, this is x2, this is y1, y2. You got it? So you do y2 minus y1, you get that, 37 minus 345. You got that, y2 minus y1. Year is that one from here. How did it change? At a steady rate of 5.2. That's for soccer. You know what? Let me keep that blue. Now, you've got to compare the track and field one. Okay, for the track and field, this is x1, this is x2, this is y1, this is y2. Now you do the slope idea again. There's your 2 points, the year minus this, and then that's going to be your y2 minus y1. You get it done here. This is your slope. Now, make sure you just figured out what we did there. We just figured out what our slopes were. Do we know anything about these things? We should know something about these things. We can come up with an equation, right? So let's look at the equation for the soccer. Okay, so they're saying when it's going from here to here, we're going to predict it from here. My rate of change from here to here is going to be at, well, 5.2, right? 5.2 what? Per year? An increase in thousands, right? So then we're going to come out here. This is the increase starting from this year. They want to know the prediction for the next year. So they're going to have that rate of change, 5.2, starting at 371. Okay, they all go together. Next thing for track and field, we did the slope of this one with those 2 dates as a time. They want to know the prediction from this year, okay, because they want to know what's going to happen from here on out. So that's that point that we start from. The rate of change would have to be 1.8. So now what happens is we graph these two things. We start off at 371. We increase at 5.2. You see that? 371, 5.2, and it goes up. Now, in this other one, track and field, they started off at 467 roughly, and they're going to increase a little bit. Where they cross is your answer. Okay, look at the question. Let's look at the question now. Use the information in the table to predict the approximate year when the number of girls participating in these two sports will be the same. So about what year do they cross-ish? Or about, and how many years will it be? Yeah? Okay. So in about 28 years, guys, they're saying here, But in about 27 years, they're going to be about the same from here. And they'll be roughly about 500,000 or something like that. Going once, going twice. That's a bad example. I don't even like it. This one the book gave us. Let's try this one here. This one's a lot easier than the one they gave us. Okay, let's try this one. So pause it and copy this one down. There's Joe. There's Josh. Okay. Now, how do I say it? Don't freak out. We're going to go through it slowly. That was a bad example. I don't like it too much. These numbers are better here. Joe and Josh each want to buy a video game. Joe has $14 and saves $10 a week. Oh, okay. So you see, for Joe, that's my B. That's my starting point. This is his rate. That's his M. So for Joe, he's going to have Y is equal to, really easy, 10x plus 14. His starting point, how much is it changing every week? Now let's look over here at Josh. Josh has 26. He starts at 26, and he's increasing that much. You got it? Now I want to tell you this much. Don't count on this, but the star people will do this a lot. They'll get this, and they'll switch it up. Okay, this, you see this? Exactly this. This, exactly this. The only reason they switch it up, because it reads more pleasant, more convenient to say, hey, well, that's what you started off at. And now he's increasing at that much. He's starting off at this, and he's increasing that every week. Are they both the same? Yes. So don't freak out if you don't see it exactly the way you do. They just started doing this just to confuse you guys. But they teach us y equals mx is b. And they just say, hey, use algebra. Can't we say this is equal to b plus mx? It's the same thing, guys. So we just kind of got to be aware of that. So now that I have these two, in how many weeks will they be the same? So kind of graph it. 14, 26, what do you think? How do I count here? And let me move this down a little bit. So I'll count by 5 if you don't mind. 5, 10, 15, 20, 25, 30, 35. Okay, this guy starts off just below 15, and he goes up 10 over 1. Now we'll go 1, 2, 3, 4, 5. Great. So this is his slope. Now let's look at his. He starts off with what? More. Oh, with less, but he increases. He pays more. This person over here starts off with more. 5, 10, 15, 20, 25. And doesn't increase as much. So this is the whole 5, 6, 7. So if you look at this, they're going to cross somewhere here. Somewhere here. Pretty cool. And how many weeks will they have the same amount? You know what? To me, it look pretty cool. Really kind of the same-ish around 3 weeks. Let's just try that. I'm just guessing. At 3 weeks, this person will have y is equal to 10 times 3 plus 14. 30 plus 14 is 44. This person over here, at 3 weeks, we're going to go 7 times 3 plus 26, 21 plus 26, 47. Ooh, no bueno, right? Let's try 4 weeks. At 4 weeks, I'm going to go with y equal to 10 times 4 plus 14. 40 and 14. 50, 40, 50. At 4 weeks, we're going to have 7 times 4 plus 26. 28 plus 26. That's my 4. It matches up already. Carry the 1, 54. So at 54, they're equal. How many weeks was that? 4 weeks. 1, 2, 3, 4. So roughly at 4 weeks, right here, 4 weeks, they're the same. Okay, guys, so I gave you some word problems there. Again, the word problems are the ones to set them up. You still graph them the same. So word problems, you still graph the same. So treat it the same. Make sure you look for the keywords. Per week, a week, every week is your slope. The other number is where they started at. If they get a discount, it could be less. If they have a, a pay or they already had some saved here. Remember, this one was about reading, saving for money. The other one was about soccer games, and then the other one was about reading pages in the book. So everything they started off with is your B. Everything that they do every week is your M. And that's it.